Okay, we're in advanced math, mods 2, 3, 4, and 7. It is Monday, May 18th. Hang in there, guys. Our last week together. This is it. If you saw the note from Mr. Fay and the administration, next week after Memorial Day weekend is simply used as, quote, makeup days, where if you've got projects or classwork or assignments that are overdue that need to be turned in before we submit our final grades, you've got a day or so to wrap things up. I will clarify everything in terms of this class, in terms of me inputting final grades and loading your report card grades and what's due on which date, that kind of thing. This Friday I'll use to clarify all that. So 4 more little learning sessions, Monday, Tuesday, Wednesday, Thursday. Your last assignment will be due Friday at noon. And once that's turned in, you're done assignment-wise for me. So Friday, the 22nd, you still need to look on Schoology. I'll have a handwritten document or note for you just to lay everything out and make sure we're all on the same page, okay? All right, you're doing a great job. Let's keep it up here. Continuing through our library of functions. Again today, Monday, 5/18/20, date in the top left corner. We're going to focus on that sheet of anything that was considered an exponential function. If we can zip through this real quick, which I think we can, that'd be great. Because remember, the goal is I'm in calculus, I'm in college credit plus pre-calculus, whatever my next level of math class is, and I see this function and I've got to boom, sketch it as quick as I can and then proceed and answer any specific questions about it once I've got it sketched. I hope that you, first of all, this is called an exponential function, not because it's got an e as its base, but because it's got a missing exponent. The base just happens to be an e. So that standard function on our library sheet, e to the x, what does that look like? Well, again, I've got no calculator out. The goal is to sketch this as accurately as I can and as quickly as I can, and I'm not allowed to touch a calculator. So I am instinctively, again, going to create an XY table. And remember, when we did exponential functions, you wanted to plug in for the missing exponent the numbers -1, 0, and 1, right? You wanted a negative number, and then always 0, of course, because anything to the 0 power is 1, and that's a great starting point. And then 1. So even though I could plug in -7, 0, and 52, why make things difficult on yourself? Pick the 3 best numbers that are able to work with in your head. So I'm going to go -1, 0, and 1. Plug those in real quick for x. Now, guys, when I take 1, I'm going to start and work my way up here. When I take 1 and I plug it in for x, I've got e to the first power, which of course is just e. Now, instead of writing e, since we're trying to quickly put dots and connect and draw a sketch over here, you might remember that the letter e is what? 2.718 as a rounded off value, because it is irrational and goes forever. So I'm going to actually write 2.718. So it's about 3 if I was estimating about where it's at on a number line. Obviously, when I take 0 and plug it in for x, e to the 0 power, anything to the 0 power is 1. Now careful, watch how I handle this. When that's a -1 that I'm plugging in and I have e to the negative first, remember that doesn't mean the answer is -2.718. Oh, e to the negative first is really e to the first, but then flipped over because it's a negative exponent. So technically it's 1 over 2.718. Now, again, I don't have a calculator out, but I'm just going to say that 2.718 is almost 3, isn't it? So I'm going to estimate. I'm going to put a little squiggly line and say that it's about 1/3, right? That says about 1/3. All right, so now on my picture, I only need a few marks in each direction, and if I make me a quick sketch, I'm going to go left 1 and up about 1/3, right 0 and up 1. Guys, that's not a linear function, is it? That third dot's important. Right 1 and up 2.718, right about there. And you'll remember from that library that we created that e to the x function looks like that. Okay? All right, so far so good. What if I have something other than e, and what if it's a negative exponent? I believe Mr. DeMarco talked about growth or decay exponentially. My prediction is, since it's a negative exponent, heck, it might be coming downhill instead of uphill. Let's see. I'm going to make an XY table. Now, careful, I am not putting -1, 0, and 1. I want to create the exponents of -1, 0, and 1. So since there's a negative in front of that x, and I'm trying to create an exponent of -1, I'm actually going to plug in 1, 0, and then -1 this time. Not that the order really matters, but just following my logic, that makes sense. Because by me plugging -1 in for x, -1 gives me the 1 that I wanted to create as that third exponent. Agreed? All right, here we go. Plug 1 in for x. That'd be 4 to the negative first, which of course is really 4 to the first, but flipped over, giving me 1/4. Don't just copy, think with me. Make sure this makes sense to you. Plug 0 in for x. Anything to the 0 power is 1. Plug -1 in for x. -1 is 1, and 4 to the first, of course, is 4. Guys, it works every time. Those quick 3 numbers on an exponential function should be enough to draw the curve in the right location at the correct steepness level, okay? So I'm going to go right a couple, left a couple, down a couple, up probably, 4, so that I can fit my 3 ordered pairs here. I'm going to go right 1, up 1/4, right 0 and up 1, left 1 and up 4. And just as we predicted, since it's a negative exponential function, it's a decay situation, and it's going downhill. Okay? All right, block 3, it says y equals 2 raised to the x minus 2 power. I'm going to make a table. I'm quickly trying to graph this function. Guys, do not write -1, 0, and 1. I want the exponent to become -1, then become 0, and then I want the exponent to become a 1. So what do I plug in here if I want the exponent to end up being a -1? Wouldn't I start with 1? Then I want the exponent to become a 0, so I would plug in 2. And then I want it to become a 1, so I'd plug in 3. Obviously, 1 minus 2 is -1. 2 to the negative first is 1/2. Plug 2 in for x. 2 minus 2 is 0. Anything to the 0 power is 1. Plug 3 in for x. 3 minus 2 is 1. 2 to the first power is 2. Here we go. Picture-wise, it takes the same similar shape to the other exponential functions. I'm going to go right a few, left a few, up a few, down a few. Plotting my points, right 1, up 1/2. Right 2, up 1. Right 3, and up 2. There we go. And I've got a curve that looks like that. Okay? And notice the adjustment as to how it looks compared to a basic one. You can make those adjustments based on the function or picture you're trying to create. Especially when I rotate and spin and make 3-dimensional figures. And then finally, you might as well throw one that looks horrible. Your reaction's probably, oh my gosh, I don't know what that looks like. Let me grab my calculator. Well, guess what? I'm still focused on the exponent, right? Because it's an exponential function. What number would I plug in for x that would cause the exponent to become a -1? So you have to think here and use that high IQ you've got. Wouldn't it be 0 as your starting point? Because watch, 2 times 0 is 0 minus 1. Oh, gives me an exponent of -1. Now I want to create a 0 as my next exponent. Uh-oh, careful. I'm going to give you 5 seconds. What number would you plug in next on your table if you were trying to make this exponent turn into a 0? Wouldn't it be 1/2? Ooh, think about it. What's 2 times 1/2? Well, that'd be 1. Minus 1 gives you the 0 we were trying to create. So that was the next choice. Now I want to create an exponent of 1, so I think I actually plug in a 1, don't I? Because 2 times 1 is 2, minus 1 gives me 1. Okay? Now we might as well plug that one in first since I just left off there. Watch what happens here. 2 times 1 is 2, minus 1 is 1. 4 to the first power is 4. Now I'm going to move my thumb. Oh, 3 minus the 4 that we just created gives me a y value of -1. So focus on your math. Everybody plug a half in for x. 2 times 1/2 is 1. 1 minus 1 is 0. This isn't -4 to the 0 power, right? This minus sign is really a -1 dot connected to the 4. 4 to the 0 power is 1. So 3 minus 1 gives me 2. Finally, plug 0 in for x. 2 times 0 is 0. 0 minus 1 is -1. 4 to the negative first is 1/4. And 3 minus 1/4 is what? 2 3/4. Now something kind of interesting is happening here. When you go to plot your points, I'm just going to go a few in each direction because we're just creating a quick sketch. 0, 2 3/4 would be right about there. Go right a half and up 2. Right 1, down 1. Oh, what's happening here? I'm connecting my dots, and isn't this going to create an asymptote up at 3? I don't think we would ever cross 3, would we? I'm just kind of thinking of a detail here. Because even let's say I plugged -1 in for x. 2 times -1 would be -2, minus 1 would be -3. 4 to the -3rd would be what? 1/64th. And 3 minus 1/64th would be 2 63/64. So it looks like this is going to get really close to 3, but there's technically a horizontal asymptote at that extra number 3 that they tacked on. Okay? All right, interesting. Now you can quickly sketch exponential functions. Tomorrow will be different kinds of logarithmic function sketches. I think Wednesday is all our trig function review, sine, cosines, tangents. Thursday, your final topic will be something called piecewise functions that I'm not sure you've had yet, and that'll wrap things up, okay? Great job. Your assignment on the back here, again, Monday, 5/18, so these 4 problems are due by noon on Tuesday the 19th. Let's stick with our routine here. Go ahead and hit pause and copy down these 4 problems, 5 to the x, e to the -x, 3 to the 2 minus x, and then finally 2 to the x plus 1 minus 4. Those are your 4 assignments, 4 functions. Guys, I gotta see a table with values. You're not just typing this in your calculator and sketching a picture and being done in 10 seconds here. I want you to be able to think your way through the quick, accurate approach to sketching functions correctly. That's our goal as we head into next year, okay? Great job. We'll see you tomorrow.